Hi guys, Mathologic here. Today I just wanted to share with you something that I would say completely revolutionized my understanding of maths, specifically physics, in the sense that I gained a very deep understanding of how formulas work in maths, and that is through the fundamental understanding of units. Now, units are, I'm sure you've seen them before. Units are the things that succeed numbers when you're dealing with measurements. So things like 5 kilograms, 5 kilometers, even in chemistry, 500 moles. All of these you could say letters, I suppose, that succeed numbers are units. They give you an idea of what type of measurement you're dealing with. How can you use units to your advantage? Well, I'm going to show you how you can turn units into your own formulas, essentially. So the first step to doing that is you have to identify the units. You need to know what units you're going to be working with and what units you want to work with, really. Step 2, change the units to symbols. This is going to make more sense later, but for example, kilograms in a formula, you're not going to get given kilograms. Often, you'll end up solving and getting an answer in grams or micrograms or whatever. So the idea of changing the units to symbols is, say, changing kilograms to, say, m for mass. 5 kilometers, you want to change kilometers to d for distance, and so on. But we'll do some examples later, and that will become more increasingly obvious. And this last step is to just rearrange. So you just rearrange to make your formula look nice. So let's get into some examples. So one of the more common examples seen in maths and physics in particular is the idea of speed, of velocity. In a question, you might be given something like, let's say, 5 meters per second. This is just another way of writing, just like that. It's the same thing. So what's the first step? We're going to identify the units. The units here are meters per second. So we can write, we'll say speed, or let's say speed is equal to meters per second. So that's step 1. We've identified our units, we've made it equal to something. So we obviously know that meters per second is speed. What's the next step? We have to change these units to symbols. So we've already got speed, that's already a symbol in itself, S. Meters, this is not a symbol. We need to change this to D for distance. And seconds is a form of time, so we'll change that to T. To rearrange, not much rearranging to do here, but we can say speed is equal to distance divided by time. Now, keep in mind, I've only derived this formula using these units, and if you look it up, this will be this is your formula for speed. It's as fundamental as that. Let's have a look at another example. In chemistry, you'll be given something called molar mass, which is another way of saying density of a molecule or an atom. I won't go into it here, but let's just use that for an example of units. So we might be given, say, 104 molar. This is the unit for molar mass. This will turn up time and time again in chemistry questions. Grams per mole, or if you like, grams per mole. Now, step 1, identify the units. This is molar mass, and however you want to denote it. Officially, molar mass is denoted using an N, and we can say molar mass is equal to grams per mole. Step 2, change units to symbols. We've already got our symbol here of N. Grams, we know, is obviously mass, so that is denoted using an M. As you can see over here, that's why we can't use M for meters in an equation, because M is commonly known as mass. Moles, and that is denoted using a capital M. So we can say, we'll just make this look nicer, molar mass is equal to mass divided by number of moles. If you look back here, grams divided by moles, it's exactly what we've got here, so lines up perfectly. I'm going to do a more complicated example now. A common thing in physics or in thermodynamics is specific heat capacity. You'll notice in your physics data book or in the question itself, you'll often be given a unit for specific heat capacity. So it might say water, for example. The water specific heat capacity is 4,190 joules per kilogram Kelvin. Per kilogram Kelvin. This is quite intimidating to look at, but it is a perfect example of how we can use our units. Let's start. So identify the unit. This is specific heat capacity, commonly denoted by C in physics. When you're doing these yourself, you don't really need to know your letter, as long as you have an understanding of what that means. It doesn't have to be, the commonly accepted letter, if you like. Step 2, change units to symbols. So we've already got our C. Joules is a measure of energy, so we're going to change that to Q. It's a commonly accepted letter for energy. Kilograms, we're going to change that to M, as seen over here as well. And we're going to change Kelvin. Kelvin is just a temperature measurement, so it's commonly used in physics instead of degrees Celsius or degrees Fahrenheit. So we're going to change that to T for temperature. We're not going to use a lowercase t because that's what is being used for time. Now this one's an interesting one to rearrange. So we have C equals Q over MT. If we rearrange this for Q, we get Q equals MCT. And if you look in any physics textbook, this will be your formula for for the energy used to heat something, using that specific heat capacity. So as you can see here, we've already derived our own formulas just using the units that are almost always provided in questions or data books. So this is really giving you the means and the tools to craft your own units. Let's just revise the steps here. First step, identify our units, and then you change the units to symbols, and then you rearrange the equation to have the subject of the equation anything you want, really. And that's the power of units, and something that has definitely revolutionized maths for me, and I hope it will for you too. Thank you very much for watching.